Hi pre-calc. So you only need to watch the first page of this video. I am going to continue on just in case someone is absent during class time, but we will do the second page in class. All right, so we're looking at the composition of two functions. And so notation-wise, notice how there is sort of something inside this other function. So these are your inside functions, and then you have the outside function. And when you are doing compositions, you always start on the inside and work your way out. So how do we say this? Notice we would say this as this is f of g of x, and sometimes we also write it with the little open dot. It's an open dot so it doesn't get confused with multiplication. Down here you'd have g of f of x. And the main thing, this is really just fancy notation for substitution, which is basically what you're doing, substituting a function into another function. However, when we have restricted domains, you are going to have to pay attention to whether what you are inputting is in the domain. So let me kind of write that out for you here. So always check that your input is in the given domain for what you're putting it into, in the given domain. And we'll do some examples so you can see all the different possibilities that might arise. All right, so we have these two functions, g of x and f of x. They each have some restrictions on their domain. So we want to find f of g of 6. And again, when you're watching a video, it's not a bad idea to kind of pause the video and try an example on your own and then start it up just to see if you got it right. So since we're going to start on the inside, we're going to first find g of 6, and 6 is within the domain of g. So when we plug 6 into the function, we get 6 minus 3, which is 3. So then we move to the outside function. So f of this now goes inside here, f of 3, and 3 is inside the domain of f, so we're good to go. So negative 2 times 3 plus 8 is going to give us an answer of 2. So f of g of 6 equals 2. All right, let's do another one. So we have g of f of 6. So we start with f of 6, and we look at the domain, and f of 6 does not exist, so yay. 6 isn't in the domain of f, so you're done. That's always nice, because we get to then move on. All right, let's find g of f of 1. So that means we start on the inside. F of 1 is in the domain of f, so negative 2 times 1 plus 8 is 6. All right, all is good so far. So then we go to g of 6, and that is okay as well. So remember, this 6 went in here. So we have 6 minus 3, and that gives us 3. So no problems there. We keep going. Find f of g of 2. So g of 2, again, g of 2 is fine. So we find g of 2. 2 is in the domain. 2 minus 3 is a negative 1. So now I'm going to find f of negative 1, but notice that negative 1 is not in the domain of our f function. So sometimes you are going to find it doesn't work on the first function. Sometimes it's going to not work on the second function. Now let's kind of get to where it really gets interesting. So you're doing it as a function. Now finding the composite function isn't hard. It's finding the domain and range of this composite given you had restrictions. That's where it gets interesting. But just doing the composite is not bad. So we're going to take f of x, and it's going to get substituted into g. So what I like to do is I like to start off with, so this is going to be g of, and what's going to get plugged in is negative 2x plus 8, because that's your f of x function. So I like to make a template out of my g. My g is x minus 3. So it's going to be something substitutes for x minus 3. So what goes there is what's in the parentheses, negative 2x plus 8. Like I said, it's just substitution. So simplifying that, we have negative 2x plus 8 minus 3. That all simplifies to negative 2x plus 5. Okay, well, no problems there, right? But now we have to look at figuring out what is the domain and range of this new function, because it looks like a linear function. It looks like, hey, everything should be all reals, but that's not going to necessarily be the case. So we start off with, we've got g of f of x is what we just found, and that was this function up here. Here was our g of f of x. All right, so the outside function is going to determine the outside of our inequality. So g has a domain that goes between 2 and 7. What goes inside that domain now is f of x. So what this turns into, f of x, sorry if I'm not being consistent with coloring, f of x is negative 2x plus 8. And so what we have to do here now is isolate x inside our inequality. So I subtract 8 from both sides and then divide. Well, I'll do it step by step. Negative 2x, subtract 8 from both sides, negative 1. Then we divide by a negative 2. Remember that when you divide by a negative, your inequalities are going to change. So negative 6 divided by a negative 2 is a positive 3. Negative 1 divided by negative 2, this turns into 1/2. That is not our standard form for writing an inequality. We tend to have the lower number on this side, so we're going to switch things so it kind of makes sense. So here, it looks like that's a potential candidate. It's not necessarily our final answer here. So let's look at if I made a number line. And on this number line, I'm going to put the domain of my original function. Actually, what I'm going to put on this number line, let me extend it here, is what we just found. We found 1/2. Here's 1/2. And here is 3. I should probably 1, 2, 3. And then I also want to put on here, compare that to that inside function f of x. F of x went from 1 out to 5. So this was the inside function, because remember, the first thing you do is put something into the inside function. So it's got to be within that inside function. But we just found a composite that went from 1/2 to 3. So what you are looking for is the overlap of those two, the inside function, which in this case was f of x, and the composition domain, and find that intersection. The intersection is going to be from 1 to 3, because 1/2 is outside the domain of f of x, so you can't, that's the first thing you're plugging into, so you can't plug in a 1/2. 4 or 5 is outside the domain of the composite function, so it wouldn't work. So our final answer here for the actual domain is going to be from 1 to 3, and that would be the actual domain. The range, I should probably label that. The range is now really nice, because to find the corresponding range, all you have to do, because you know everything is okay now, you just plug in those endpoints into your composite. So that means we're going to be plugging in I'm going to do it over here to the side. So negative 2x plus 5, that was our composite function. So negative 2 times 1 plus 5 is 3. Negative 2 times 3 plus 5 is negative 1. So the corresponding range is going to be from negative 1 to 3. And again, there's two different ways. You can write it here with the inequalities. You can also write it with the brackets. So I could have also written my domain as square brackets because we are including the endpoints. If I had done a soft parenthesis type bracket, that means it's open at the endpoints. So this might be an easier way for you to write it. Okay, let's do this one more example. And then you can stop watching the video because we'll complete the next page in class. So over here I have find f of g of x. We're doing example f. So if I go back up, we're going to now take g of x and plug it into f. So this is going to be f of x minus 3. And so that means I'm going to be taking negative 2 times something plus 8. X minus 3 is going to go in there. And then we simplify. So that's going to give me negative 2x plus 6 plus 8. So our composite function is negative 2x plus 14. Now again, we go through, this is a good place for you to pause to see if you understand that concept of how to find the true domain of the composite function. We're finding the domain of f of g of x. So again, the domain of f, because it's outside, goes on the outside. And then g of x as a function goes inside, and we solve for x. So this one's an easy one. We add 3 everywhere. Here's x, we add 3. Again, maybe you should put like a parenthesis. This is a potential. So now we want to compare. We compare 4 to 8. So 4, 5, 6, 7. This was our composite function, f of g. And we compare that to the inside function, because the inside function is our first candidate for what we're going to plug into. G of x goes from 2 to 7. So from 2 to 7 is g of x. The overlap is going to give us our actual domain. So the overlap is going to be from 4 to 7. So my domain is going to be all the x from 4 to 7. And again, to find the corresponding range, it's a little bit easier. All we have to do is plug our domain endpoints into the composite function. So I have negative 2 times 4 plus 7. So that's going to give me, did I do that right? 7 minus 8 is negative 1. Oh, that's a 14. Okay, I knew there was something wrong there. 14 minus 8. 14 minus 8 is 6. And then we go negative 2 times 7 plus 14, which is going to give me 0. So my range is going to be 0 to 6. Okay, that's it for now. We will finish the rest tomorrow.